Bright Tuty. Every student matters.
Now these questions are very simple for you. Find the zeros of following quadratic polynomials and verify the relationship between zeros and coefficients. These are very simple questions for you. So I'll just give you a hint and then leave it to you. It can be factorized as, right, by splitting this middle term. So if I take x as common, so this is x equal to minus 2 or x equal to 4. These are the two places where this polynomial will give us value 0. So these are the zeros of this polynomial. And to verify the relation, we know that sum of zeros is equal to minus 2 plus 4, and from here sum of zeros should be equal to minus of coefficient of x divided by coefficient of x square. So it is giving me 2, and minus of coefficient of x is minus of minus 2, and coefficient of x square is 1. So yes, the relationship is verified. Similarly, for product of zeros, what is the product? It is equal to minus 2 into 4, which is equal to minus 8, right? And from this one, it should be equal to constant term divided by coefficient of x square, which is equal to minus 8 by 1 equal to minus 8. So yes, the relationship is verified, right? So these questions will become very simple for you. For this question, what you can do is, again you should factorize it, right? Otherwise, if you notice, it can also be written as 2s squared plus 1 square minus of 2 into 2s, right? So this is nothing but 2s minus 1 whole square. So s will be equal to 1 by 2, 1 by 2, right? So what is sum of roots? Sum is 1 by 2 plus 1 by 2 equal to 1, right? And from here it should be equal to coefficient of s divided by coefficient of s square with a negative sign. So what is coefficient of s here? It is minus 4. What is coefficient of s squared? It is 4, right? So these get cancelled, minus minus plus, it will give me 1. So yes, the relationship is verified. Similarly for the product, what is the product here? Product is 1 by 2 into 1 by 2, it is equal to 1 by 4, and from our relationship it should be equal to c by a, constant term, by coefficient of s square. So it is also equal to 1 by 4. It is equal to constant term divided by coefficient of x square, right? So yes, it is verified. Okay. So let's leave this question for your practice. Okay, you just factorize it and then verify the relation. This should also be really simple. Okay, there seems some mistake in this statement, but I would have left it for your practice. So this question can also be taken as practice question, because you just have to factorize it by splitting the middle term. You can do it like this: minus 4x plus 3x minus 4, and then find the zeros and verify the relationship. So do it as your practice. Similarly this one. So let's move on to this question now. Find a quadratic polynomial, each with the given numbers as the sum and product of its zeros. So I will ask you to use the formula that we derived there. The formula, direct formula, says x square minus sx plus p, where s is sum of zeros, p is product of zeros, right? Or what we can do is, we need to find a quadratic polynomial. Find a quadratic polynomial. He has not written the find the quadratic polynomial. So it will be one of the quadratic polynomials with these zeros, right? because if I write x minus 1 by 4 into x minus of minus 1 plus 1, right, it will be one of the quadratic polynomials made with these zeros, right. Now if I multiply it with some constant a, it will be another polynomial. I keep changing the value of a, this will be another polynomial. If I make it 3, this will be another polynomial where zeros are same, 1 by 4 and minus 1, right. So with these zeros, one of the polynomials will be equal to x square minus sum into x plus product, right. So it will be equal to x square minus, this will become minus 3 by 4, 1 minus 4 is minus 3, minus 3 by 4, so minus minus plus 3 by 4 x, this will become minus 1 by 4. Now if I multiply it by 4, it will give me 4x square plus 3x minus 1, right. Why was I able to multiply it by 4? Because it won't make any difference to the zeros. So this is one of the quadratic polynomial here, right. I could have multiplied it by 8 also. This multiplication was just to make the expression simpler, right, because if I write, I explained it to you here that if I put x equal to 1 by 4, this bracket will become 0. If I put x equal to minus 1, this bracket will become 0. Now what the constant outside is won't matter for the roots of this equation or zeros of this polynomial, right. So this is our required quadratic polynomial. For this one, what you can do is, what is sum? Sum is root 2 plus 1 by 3, which is equal to 3 root 2 plus 1 by 3. And what is product? It is equal to root 2 into 1 by 3, which is equal to root 2 by 3. So the quadratic polynomial will be x square minus sum into x plus the product. Now to make it simpler, we can multiply it by 3. So 3x square minus 3 root 2 plus 1 into x plus root 2 by 3 is our quadratic polynomial. This is one of the quadratic polynomials because I can also multiply it by 2, 3, 4, right. So it will keep giving me other quadratic polynomials with same zeros. Okay. Okay. So till now I have been using direct formula. Now let us say if the zeros are 1, 1. Okay. Let's look at this question. If the zeros are 1, 1, what will be the quadratic polynomial like? X minus 1 into x minus 1. Why? Because when 1 is a 0, there should be x minus 1 somewhere in the quadratic. Because 1 is 0, so x minus 1, when x is equal to 1, it will become 0, right. And both the zeros are 1, 1, so the quadratic will be like this. So my p of x, let's say, will be equal to x minus 1 squared. Okay. So it will be x square minus 2x plus 1. All right. So this is my one of the quadratic polynomials with roots 1, 1. Okay. So this is how you can think. Let us say there is 0. So I can write it as x minus 0 into x minus root 5. It will again give you the required quadratic polynomial. Okay. Similarly for this one and this one. Let's do one of these and then we will move on. For this fifth case, this sum is minus 1 by 4 plus 1 by 4, which is equal to 0. What is the product? It is equal to minus 1 by 4 into 1 by 4, which is equal to minus 1 by 16, right. So one of the quadratic that is required, let us say px, it will be equal to x square minus sum is 0, 0 into x plus product minus 1 by 16. This is 16. Okay. So this can also be written as x square minus 1 by 16, or you can write it as 16x square minus 1 by 16, doesn't matter, right? It won't matter because this is one of the quadratic polynomials which will give me zeros as minus 1 by 4 and 1 by 4. Other polynomials can be like this, 16x square minus 1, right? Or I can multiply it by 2, 32x square minus 2. All these polynomials will give me same set of zeros. Okay. For 4 and 1, you can write it as x minus 4 into x minus 1. It will again give you x square, the sum of roots as plus 4. You can multiply these brackets and arrive at this conclusion, or you can directly apply x square minus sx plus p. The choice is yours, but anyways we will get the same answer, because in mathematics if we go by different paths it will lead us to the same answer. Okay. So thank you for this lecture. We will now meet at the next lecture where we will discuss division algorithm in polynomials, right? Thank you.